Hey everyone, welcome back for another deep dive. Today we're looking at something that I think you'll find really interesting. It's all about how one project in Singapore is using open educational resources to really shake up how we teach physics.
Yeah, it's a pretty cool case study in how technology and collaboration can make a real difference.
So to get us started, the main thing we'll be looking at is this blog post about a teacher training session that happened back in 2013 at the National Institute of Education in Singapore.
From what I gathered, it seems like it was a pretty big deal.
Definitely.
Yeah.
And it makes sense when you think about it. This training was all about giving teachers the tools and the know-how to create and use interactive physics simulations.
Simulations.
Yeah,
Now, those are a game changer when it comes to visualizing those tricky physics concepts.
for sure. And the facilitator of the session, a guy named Looking, seems to be like a real champion for this whole open source physics education movement.
Yeah, it sounds like he's super passionate about it, and it's contagious. Reading that blog post, I felt myself getting excited about the possibilities, too.
Totally. So they were focusing on this tool called Easy Java Simulations, EJS for short. Have you ever worked with that?
I've seen it around, but haven't had a chance to really dive in. But from what I understand, it's a pretty powerful platform for creating and customizing physics models.
It seems really versatile. And in this particular project, they were specifically adapting existing EJS simulations to align with the Singapore physics syllabus.
So it's not just a generic tool, they're really making it work for their specific needs.
Exactly. And get this, it was a huge collaborative effort. Teachers from a bunch of different junior colleges were involved in designing worksheets and activities to go along with the simulations.
Wow, so it's like a whole community coming together to create these amazing resources.
Exactly. Places like River Valley High School, Yushin Junior College, and more. And you know what? Their hard work paid off. This whole project ended up winning a Ministry of Education and Energy Gold Award in 2012 for something they called Gravity Physics by Inquiry.
Wow, a Goldie Award. That's impressive. They must be doing something right.
Right. Okay, so let's get into the nitty-gritty of the simulations themselves. The blog post mentions that they covered 9 different topics during the training.
Yeah, they covered a pretty wide range of concepts. Everything from basic stuff like collision carts to more complex ideas like Kepler's system and gravitational fields.
It's like a physics buffet, something for everyone no matter where they are in their understanding.
I like that analogy. And what's really cool is that they didn't just stop at creating the simulations. They went the extra mile to really think about how to use them effectively in the classroom.
Yeah, they really put a lot of thought into the pedagogical side of things. Which simulations really jumped out at you?
Well, one that caught my eye was the one on falling magnet through coil. It tackles electromagnetic induction, which is always a tricky concept to teach.
Ooh, yeah, electromagnetic induction. It's one of those things that just makes your brain hurt a little. But I bet seeing it in action in a simulation would help make it click.
For sure. And it's not just about seeing it. It's about being able to manipulate the variables. Change the strength of the magnet, the speed of the coil, and see how those changes affect the induced current.
It's like giving students a virtual lab where they can experiment and explore without any of the limitations of a real-world setup.
Exactly. And another one that I thought was really neat was the ripple tank simulation. It's designed to show wave interference patterns, but what's really cool is that it offers these super realistic 2D and 3D visualizations.
Oh, wow. That sounds way more engaging than the ripple tanks we used to use back in the day. Remember those? With the little dippers and the overhead projectors?
Oh, yeah. Those were fun, but messy. And sometimes it was hard to see the patterns clearly. With a simulation, you get that precision and control that you just can't get with a physical setup.
It's like a physics teacher's dream come true. So they were clearly putting a lot of effort into making these simulations as accurate and engaging as possible. But did they mention any challenges they faced in creating them?
Actually, yeah. When they were talking about the gravitational field simulation, they mentioned that it was kind of tricky to render the specific physics equations involved.
That makes sense. I mean, gravitational fields are notoriously complex. It just goes to show the level of detail and accuracy they were aiming for.
For sure. They weren't cutting any corners. So all these simulations sound amazing, but here's the big question. Can anyone actually access them?
That's the beauty of it. They're all open educational resources, so they're freely available for anyone to download and use. The blog post even has links to where you can get them.
That's amazing. It really embodies the whole spirit of sharing knowledge and making education accessible to everyone.
I'm so on board with this whole open educational resources movement. It's like a breath of fresh air in a world where everything seems to be about profit and exclusivity.
I couldn't agree more. It's about time we started prioritizing access and equity in education.
Okay, I'm getting a little carried away here. We still have a bunch more simulations to explore, right?
Yeah, there are a few more that I think are worth discussing. Each one offers its own unique insights and learning opportunities.
All right, let's dive back in.
Yeah.
I'm eager to see what else these innovative educators have come up with.
So moving on, we have one that I think you'll find particularly fascinating given your interest in all things space. It's the simulation on Kepler's system.
Oh yeah, Kepler's laws are like the foundation of our understanding of planetary motion. It's incredible how he figured all that out. The elliptical orbits, the relationship between a planet's distance from the sun and its orbital period, all just from observation.
It really is mind-blowing. And this simulation really brings it to life. You
Yeah.
can actually visualize those orbits, see how the planets move at different speeds depending on their distance from the sun. It's like a virtual planetarium.
I bet that's so much more engaging than just reading about it in a textbook.
Yeah.
And speaking of space, did I see something about a geostationary satellite simulation too?
You did. And this one's all about the physics of orbits, specifically what it takes for a satellite to stay in a fixed position above a particular point on Earth.
Ah, geostationary satellites? Those are the ones that are responsible for all sorts of things, right? Like communications, navigation, weather forecasting.
Exactly. They're essential for our modern way of life. And this simulation lets students explore the factors that make those orbits possible, things like altitude, speed, and gravitational pull.
It's a great way to connect those abstract physics concepts to something that's actually really relevant to their lives.
Absolutely. Now, we've been talking about some pretty complex simulations so far, but there are also a few that focus on more fundamental physics principles, just to bring things back down to earth a little.
Good idea. Sometimes it's helpful to go back to the basics.
Exactly. So one of those is the simulation on projectile motion, and it's
Yeah.
all about how objects move through the air under the influence of gravity. Like
Mhm.
when you throw a ball or shoot an arrow.
Right. It seems simple, but there's actually a lot of physics going on there, like the launch angle, the initial velocity, the effect of air resistance.
Exactly. And this simulation lets students play around with all those variables, see how they affect the trajectory of the projectile. I bet they could have a lot of fun with that.
Oh, for sure. It's like a video game, but with educational value.
The best of both worlds. And speaking of classic physics concepts, there's one on superposition of two waves. You remember wave superposition, right?
Vaguely. It has something to do with how waves interact with each other, right? Like when they combine to create bigger waves or cancel each other out.
You got it. And this simulation really helps visualize those interactions.
Mm.
You can adjust the properties of the waves, their frequencies, their amplitudes, and see how those changes affect the resulting interference patterns.
Oh, I see. So it's like those ripple tank experiments we used to do, but in a much more controlled and precise environment.
Exactly. And speaking of electric fields, which can be a bit hard to wrap your head around, there's the two-point charges simulation. It allows students to visualize those invisible forces of attraction and repulsion.
Ooh, electric fields. Those were always a bit of a mystery to me. So this simulation actually shows the electric field lines.
It does. And you can manipulate the charges, see how the field changes as you move them closer together or farther apart. It really helps make those abstract concepts more concrete.
It's like giving students X-ray vision for the world of electromagnetism. I'm really impressed with the creativity and ingenuity of these educators. They've really taken these complex physics concepts and made them accessible and engaging.
It's inspiring, isn't it? And it just goes to show what's possible when we embrace open educational resources and a collaborative approach to teaching and learning.
Absolutely. Now, before we move on from these simulations, is there one that really stands out to you as a prime example of the power of this approach?
It's tough to choose just one. They're all so well designed and thought out. But I think the one that really captures the essence of this project is the ripple tank simulation. It's both visually stunning and conceptually rich. It really allows students to see and understand those complex wave interactions in a way that just wouldn't be possible with a traditional ripple tank.
I can definitely see why that one would be a favorite. All right, I think we've covered the simulations pretty thoroughly. Should we shift gears a bit and talk about the bigger picture? You know what this project means for the future of education?
Absolutely. I think there's some really important takeaways here that go way beyond just physics.
So we've seen all these amazing physics simulations and how much potential they have for engaging students. But what I find really fascinating is what this project says about the future of education. It's not just about physics. It's about a whole new way of thinking about teaching and learning.
It really is a paradigm shift. And open educational resources are at the heart of it. They're breaking down those barriers that have traditionally limited access to quality learning materials.
It's like democratizing education, right? Making knowledge available to everyone regardless of their background or their socioeconomic status.
Exactly. It's about leveling the playing field. And it's not just about access either. It's about empowering teachers, giving them the flexibility to adapt and customize materials to meet the unique needs of their students.
I love that. It puts the power back in the hands of educators who are on the front lines and really understand what their students need. It's like a shift from a one-size-fits-all approach to something much more personalized and responsive.
And it fosters a sense of community too, right?
Yeah.
With open resources, teachers can share their ideas, collaborate on projects, and learn from each other. It's a win-win for everyone.
Absolutely. And this kind of thinking isn't limited to physics either. I can imagine open educational resources transforming learning in all sorts of subjects, from math and history to art and music.
I completely agree. The potential is limitless. And it's exciting to see this movement gaining traction all over the world.
It's really inspiring. Thinking about all of this makes me wonder if there are any similar initiatives happening closer to home. I'd love to see more schools and educators embracing this approach.
I'm sure there are. And that's something I'd encourage you to explore. Maybe this deep dive has sparked some ideas or inspired you to seek out similar projects in your own field of interest. See what's happening in your local community, or even start something yourself.
You're right. We can all be part of this movement. We don't have to wait for someone else to lead the way.
Exactly. And that's what's so exciting about open educational resources. They empower each of us to be agents of change in our own communities.
Well, this has been an incredibly enlightening conversation. Thank you so much for sharing your insights with me today. I'm feeling really inspired and energized.
It was my pleasure. I always enjoy exploring these cutting-edge ideas and thinking about how we can shape the future of learning.
And to our listeners, thank you for joining us on this journey of discovery. We hope you found it as fascinating as we have. Remember, learning should be an adventure, a lifelong pursuit of knowledge and understanding. So keep exploring, keep asking questions, and keep diving deep.